calculate, yes, peak current we have taken, maximum position reached by the current during positive off or negative off, which is nothing but phi only. Now I am introducing one concept called peak to peak current. Anyone try to give the definition? IP to peak. Peak or maximum value, both are same. Peak to peak current means what? The current flowing from positive peak to negative peak. Negative peak means don't think it is minus 5. It is flowing in opposite direction. So the value of the current. So I will not dictate this definition. You remember. What is peak to peak current? The value of the current. The value of the current from positive peak to negative peak. So positive peak is 5 and negative peak is also 5. So total we take only
0.
the, see, that's what the mistake here. So we have to take only the energy, not the direction. So definition is saying that the value of the current from positive peak to negative peak, only the strength, only the value. So it is nothing but 5 plus 5 is nothing but how much? 10. All of you
5 plus 5,
understand?
10.
It is, we cannot take it is negative. See, positive peak and negative peak we are using based upon our convenience, but the currents are flowing in opposite direction. Okay, so in your house, all of you, energy meter you are having, no? All students. Yesterday have you seen the pole? From the pole, all of you, AC current, all of you, today only you check after the class. From the pole, I am drawing the pole connection. You see, near your house, you will be having the pole. Pole will be having 4 wires. Okay, and to your house, only 2 wires will be coming down. Only 2 wires. And you are having one meter in your house. Yes or no? Everybody is having no meter?
Yes, sir. Yes, sir.
Yes, right. So now you see, to that meter, only 2 wires will be coming to your house. One wire will be red wire. One wire will be red wire, which is called the energy wire. As it is introduction class, I am saying energy wire. Another wire is nothing but neutral wire. Okay, all of you might have seen. So as per the government rule, energy wire means the wire which has got the energy, and the wire which is not having energy, it is zero wire. All of you might have seen in the movies, bomb detector people. Bomb detect people, what they are going to do? They will be in a confused state whether they have to cut to defuse the bomb. They have to cut the red wire or the black wire. Have you experienced that scene in movies and serials? All of you? Yes. Bomb. Yes. So as per the government rule, the red wire we are supposed to cut. When we cut the red wire, what's going to happen? Energy is equal to 0. Okay, but time being, I will take this particular concept. So what is this, sir? You can ask one question, sir. You are saying AC current, okay. What are these peak currents and peak to peak currents? These are used only for theoretical explanation. Is there any practical use of peak current? No. No practical use of peak to peak current. These are only for the simple understanding the behavior of the AC current. Now you tell me, what is the definition of AC current? Anyone student? The current which flows in 2 different directions and always changes with time. So here we write time here because the value is not constant. It is changing. Now one more question I am asking all of you. Follow the diagram here. Here I am drawing 2 and here I am drawing the 3. Now you tell me, what is the name? What is the meaning? So at time t is equal to 2 seconds, the current value is nothing but, let us say the current is 9 amperes. And at time t is equal to 3, the current is how much? Let us say it is nothing but 12 amperes. So the value of the current at any instant of time is called dash current. Anyone tell me? The next definition. All of you, peak current is perfect, no? All of you, right? Now we are moving to the next definition, which is instantaneous current, all of you. So instantaneous current. What is the definition of instantaneous current? All of you can see now. Read this one, anyone student?
The value of the current at any period is called instantaneous current.
Okay. Sir, this yes. What is the use of this instantaneous current means? I will tell you. Instantaneous current is used for only mathematical formula representation of AC current. AC current is flowing through the wire. Sir, write the equation of the AC current. So instantaneous current is used to represent mathematical formula for AC current. So everyone will say, okay, AC current is flowing through the wire. What is the formula for DC current? We write only I. Okay, but for AC current is having peak value. So what is the peak value indication? I will take you to this one. See, these concepts are new. You must take certain time to understand. All of you, this one you peak current. So I'm writing one word. Always AC current peak value is represented by the letter. Just now we have taken I suffix M, or in some books they write IP. So all of you, what is IM? All of you, anyone tell me? Maximum current or peak current, highest position reached. Okay. So all of you, now you see, we are taking, now listen carefully. What all engineers has mentioned, I can call this particular AC current also as, AC current is also called as, I'll share this one. Yes. You read out this one student. This
Sine wave.
Sine wave or AC current
or
or
AC
bidirectional
current or
current.
bidirectional current.
So all the engineers, they can use the word AC current as it is changing with time and it is flowing in two different directions, bidirectional current. And for engineering calculations, why we are calling wave means it is continuously 24/7 flowing through the wire, so that current can also be called as wave. And why you are saying the trigonometric function sine, why not cot, why not cosecant? Remember, all trigonometric functions can be easily converted to sine. All of you, why you are, I can also write cot wave, I can also write the cosecant wave, but if I am doing the simplifications, so sine value will obtain the easiest answers. Therefore, so this AC current is also called as sine wave. All of you are understanding? So now, if I am writing the equation, what is the formula for DC current? Anyone? I is equal to, we write V by R. Yes or no, all of you? That is for only DC current.
Yes, sir.
Now you see today onwards, what is the formula for AC current means I is equal to, okay, and AC current has got peak value or maximum value. I'm writing here, you also write along with me. I is equal to IM, yes, it has got positive peak and negative peak, and that AC current is represented mathematically in which trigonometric function? Sine. Why you are writing sine means it is changing, it has got multiples. Okay, so I is equal to IM sine. I can write Q means theta there. I is equal to IM sine theta. Sir, why you are writing theta means, all of you, I'll just follow this particular diagram once again. Let us go back to this particular digital screen. So on the screen, what you are able to see? The whiteboard, right?
Yes, sir.
So all students, draw the AC current means, yes, just follow this one. Draw the AC current means, see I'm drawing right now. Draw the AC current means I can say that AC current, okay, this is the AC current. It is changing in different directions. Therefore, I can take the x-axis as theta. Current is changing at angular direction. Sir, why you are writing theta? What is the real reason? Means all of you tell me, I'm telling you, any object is rotating in circular direction, that object behavior can be represented with angle theta. Now you tell me, in your house, fan is rotating. Fan is rotating in circular direction or in a straight forward direction? All of you, fan is rotating in circular direction or in a linear or straight forward direction? Any student? Yes, the voice is audible or not? Due to this internet problem, okay, now, right, is it okay? Voice is clear now?
Yes, sir.
Okay.
Yes,
now
sir.
you see this diagram, all of you. Yes. AC current, all of you see on this digital board. AC current can also be represented x-axis with theta. Sir, why you are writing theta means any object which is rotating in circular direction, that object can be represented by the theta. For example, in your house, fan is rotating in linear direction or circular direction. That is, Fan is rotating in straight forward direction or in circular direction?
Circular.
Circular. Washing machine rotates in circular direction. Therefore, the current flowing through the washing machine, the current flowing through the fan is represented with respect to angle theta. So what is the formula of current flowing through this fan means I is equal to, tell me, AC current.
Im sin Q.
I am sin theta. I am sin theta. All of you today onwards, remember I is equal to I am sin theta. You write there. You write there in the notes, draw the diagram. Okay, sin theta I am writing. So I can also write in this manner. I can also say theta is equal to any object which is rotating in circular direction. I can say theta is equal to omega into t. So I can write the formula I is equal to Im sin omega t. Omega is equal to angular circular frequency. Omega is equal to 2 pi f. Okay. Now you would see all of you. Now come on. So what is the formula for AC current? Anyone tell me now? AC current I is equal to
Im sin theta.
Sin theta. So I can also write. Now you read this one. All of you. Now you read what we have written here.
I am sin omega t.
In the brackets omega t. Okay, so I can write in different forms. I can write I is equal to sin theta or I am sin theta and I is equal to I am sin omega t. So this is what the instantaneous current. So the value of the current at any period of time is called instantaneous current. But the formula is, what is the use of instantaneous current? Can instantaneous current flow through the wire? No. Peak current flows through the wire? No. Which current flows through the wire? AC current. AC current is a combination of peak current, peak to peak current, instantaneous current. Now I hope you have understood, all of you. So define AC current means AC current, second definition is AC current is a combination of peak current, peak to peak current and instantaneous current. So what is the formula for instantaneous current, all the students? I is equal to Im sin omega t. So now what is the current which we are getting in your house? Anyone tell me what is the formula for the current which we are getting in our house? I is equal to Im sin omega t. Understood all the students? Now tell me the formula for voltage. Now voltage means V is equal to, see I am writing Vm, V suffix m. Come on, tell me. Sin omega t.
Sin omega.
Omega t.
You write there all of you because this is important. So draw the graph of AC current. You write I is equal to Im sin omega t, and for voltage V is equal to Vm sin omega t. So few textbooks they explain with voltage, few textbooks they explain with current. We follow with the current. Okay. So after this instantaneous current, we are supposed to take the most important current. Next current is nothing but, all of you, average value or average current. So I can use this one. In the examination, if they ask you average value means it is actually the name is average current or voltage. It is visible on the screen, all of you, right?
Yes, sir.
So remember one formula. What is average current? Sir, average current is flowing through the wire? No. Average current, because of average current, one bulb is on? Answer is no. So why you are discussing this instantaneous peak current means they are the part of the AC current. AC current is a combination of peak current, instantaneous current, peak to peak current and average current. I will draw one diagram, you will understand. So for your understanding, I'll show. So first all of you go through this formula. Average current is equal to, what is the formula? Area of the curve.
Length of the curve.
All of you just write that formula, area of the curve by length of the curve. Okay. So in our examination, they will ask you, derive the equation for average current. Derive the equation for average current. Now you see in what way we are going to do the derivation. First derivation. So slowly I will explain. You'll understand that's one. So first, before doing that, I would like to show you one graph. Now you see, first you see this one. All students, this green color diagram is visible now?
Yes, sir.
You can take a screenshot if you want. It will be there in the material. So this I'm writing, I can write here current or voltage. You can write here I. And it is changing. You can see this one. So AC current. First one, what is there? Peak value. Peak value. Here they have written in terms of voltage. So peak current, AC current is a combination of peak current. And what is this one? Peak to peak, that is from positive peak to negative peak. Next, it is a combination of instantaneous, which is not shown, average current. So define AC current means there are two definitions. AC current which flows in two different directions, and it is a combination of how many currents? Instantaneous, peak current, peak to peak current, average current so far. Next current is RMS current, we'll discuss. So what is the formula for AC current? Here we have written. Anyone read out? I is equal to
I is equal to Im sin omega t.
Im sin omega t.
Im sin omega t. Now all the students now do the derivation along with me. You keep open your notes. Okay. So now let me modify this one. This derivation is important. You just start doing practicing the derivation along with me. What is this average current? We'll discuss practically. See, average means everybody know, but I will not take in a simple basic manner. See all of you. Diagram is visible now on the board now, which I'm drawing.
Yes, sir.
Okay. Now one simple question I'm asking. Just tell me this one. See, what is the average of this signal? This is positive, okay, and this is negative. Average means more, how many regions are there? 2. Average means positive value. Let us say this is +1, positive, and next one is nothing but -1. And how many curves are there? 2. So what is the answer, all of you? +1 -1 divided by 2. How much you will get? 0. So all of you, average, remember all of you can write in your notes, average value of pure means equal positive of cycle and equal negative of cycle. Average value of pure sine wave is equal to 0. You can write that one. So what is the average current which you are getting in your house? Anyone tell me? It is 0, because average value of pure sine wave, pure current, pure AC current is always 0. It contains equal positive region and equal negative region. Average, if you are taking, it is equal to 0. Okay. Therefore, average value, next line you write. Average value is always explained for only off cycle. Now you draw this diagram. All of you write that statement. Average value is only explained for off cycle. All of you just draw that graph which I am drawing right now. So now I am assuming here the x-axis is nothing but theta. Okay. So what we are having here, peak value. Draw along with me, all of you. So here this point is nothing but peak value. We can write above the curve, or else here Im. Understood? All of you have drawn this one. So what is the average value of pure sine wave? Objective type question. It is equal to 0. Average value is explained only for off cycle. All of you see here. So current is starting from 0. I can call this one as the see 180 or any angle I can give. T1 at time where it is coming to the end point. So all of you in our language, in the engineering language, you see. So this is, you see this graph. This is off cycle. Off cycle means it will be there from 0 to pi. Pi means 180 degrees. Okay. And next cycle starts from pi to 2 pi. Anyone tell me what is 2 pi? 2 into 180 in terms of angle. It is 360. When, yes. Current full cycle means 360. Off cycle means 180. Understanding, all of you? Fan is rotating in one complete cycle. Fan completes one full cycle means the angle is 360. Off cycle means 180. So here we take, yes, average current is explained only for off cycle. You just draw along with me. Okay. Those who are not drawing along with me, they will fail in exam. Remember this point. So when I say, you must draw along with me. Okay. So average current, most important definition is average current. What is the formula for average current? Area of the curve by length of the curve. Because this is a graph. Okay. So we must draw this diagram. Now all of you, what is the length? Length means the difference between highest position reached by the current minus initial position. So what is the length of this curve? Anyone tell me? Length is nothing but see length, yes, very good. It is starting from initial position 0 and reaching the final position. So the length is nothing but 180 minus 0, which is nothing but pi minus 0, or simply we can write pi. Now what is the area of the curve? Area means in maths you have studied the integration. I will tell you one practical example, all of you. I have given you one apple. Okay, you have cutted that apple into small pieces. That means you are differentiating the apple. If I am asking you to give me the smallest particle of the apple, means we write d apple by dx. Understanding, all of you? Yes or no? The apple is divided into smallest particle. And if I am asking, after cutting the apple, give me the complete apple. So what you are going to do? Again, you are going to place that apple in the mixie. You are going to make that in the form of a juice. Now I want to take complete apple. So what is another name for integration? Anyone tell me? Integration, another name is total. Understanding, all of you? Intermediate, you are having no integration.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, total. So if I want to calculate the total area covered by this current waveform, integration of what is the minimum value? 0. And what is the maximum value, all of you?
Pi.
Maximum value is pi. Understood, all of you? So there I have to use the integration. So if somebody is giving you the apple, you are cutting that particular apple, and once again they are asking, give me the complete apple in liquid form. So total area occupied by the apple is taken from its integral. So now you see, all of you, have you drawn this one? So what is the average current? Average current is represented by, I am writing with the indication IAVG. You write along with me, all of you. IAVG. So clearly you write equal to, now I'll take you to the derivation. So give me 1 second. Average current. So now on the screen you are able to see the average current, all of you. Derivation.
Yes, sir.
All of you see. So what is the formula? We'll make it fast. Here you write
Area of the half cycle by interval.
length of the curve. Area of the curve. Curve means half cycle here. You must draw this diagram and this derivation. I average equal to area of the curve by length of the curve. So what is the length? Just now we have done. What is the length, all of you?
Pi.
Pi. That is pi minus the highest position minus minimum position. It is pi. And now in the area. Area means total integration. Integration from which value to which value? 0 to pi.
0 to
Pi. And which quantity we are taking? Current. So current formula is what? I. So I. And current is changing with respect to theta. Therefore, I have taken here I d theta. All of you understood here? All students? Formula for current I. Is it clear?
Yes, sir.
So we are discussing for the current. Okay, now we have taken. But what is the formula for current? Anyone? AC current formula, you tell me. Anyone, student? Im sin omega t.
Im sin omega t.
Here I have written in my equation graph, I have written theta. So whether it is capital letter or small letter, it doesn't matter. I is equal to Im sin theta. Okay, I have written here sin theta, and it is differentiating with respect to theta. Is it clear, this statement, all of you? Now, Im is constant. Im is the maximum value. So Im is constant. You bring this one outside. So integration we are applying. Integration of sine is how much? Anyone tell me?
Minus cos.
Minus cos.
Integration of sine theta is minus cos theta under the limits 0 and pi. So what's going to happen? Im is outside only, divided by pi outside only. Minus you bring outside cos of 180 minus cos 0. So what's going to happen? Cos 180 is how much? Minus 1.
Minus 1.
Okay, if you substitute cos 180 minus 1 minus cos 0 is how much? 1. Yes sir?
1.
So minus 1, how much you will get? Minus 2. And already we are having minus, therefore you will get here 2. Okay, I repeat this one once, I explain this one once again. Minus you write outside the bracket, and cos pi minus cos 0. Cos pi is how much? Minus 1. Minus cos 0 is how much? 1. So minus 1 we are going to get inside the brackets, which is minus 2, and outside already we are having minus, therefore it is 2. So 2 Im by pi. So now all of you see here, denominator, you just check here, this particular value. Pi means in the denominator, if you do this division, Pi 3.14. Anyone student open the calculator? You tell me 2 divided by 3.14. You do, all of you. Pi you have to take in radians 3.14.
2 divided by
3.14 you do.
0.63.
0.637. Okay, so into Im. So what is the formula for average current? All the students today onwards you have to remember average current is a part of AC current, and average current is equal to how much? 0.637 into peak current or maximum current. Understood, all of you? So remember this derivation you'll get in the examination. Define average current and derive the expression for average current. So what is the formula for average current? Come on.
0.637
IM.
Okay, all of you
IM.
yes, all of you, if you want, you can take the screenshot and you all give the material. Now I'm taking back to you people to the material. So average current we have taken. Sir, why you are explaining the average current? Means AC current is the combination of, all of you see where the average current is shown here, average value. Average current is a part of the AC current. All of you are able to see this graph now? Yes or no?
Yes, sir.
So what is the definition of average current? Average current is AC current flows in 2 different directions and it changes with time. Therefore, it is called the bidirectional current. Okay. But AC current is a combination of peak current, peak to peak current, average current and instantaneous current. And last current is what? Anyone tell me? In chemistry intermediate, you got RMS current. Okay. That RMS is different here. Root of the mean of the square of the quantity. So tomorrow's class, never miss tomorrow's class. Tomorrow's class, we are taking the RMS current derivation and importance and problems on RMS current and average current. So second chapter, second AC current, what problems we are having means we are having first problems on RMS current and average current. So the current which we are getting to your house, what is the name of that current? AC current. But that current is a combination of, tell me, that current is a combination of how many currents? AC current is a combination of
Currents,
all the students.
peak
Current,
current,
peak to peak
average
current.
instantaneous current.
Yes. Now, what is the formula for instantaneous current? Anyone student, fast. Instantaneous
IM
current.
sin omega t.
IL.
Okay.
Sin omega t.
See, when I say instantaneous current or only the AC current, the formula is I is equal to Im sin omega t. What is the formula for the average current?
Area of the curve by length
That
of
is
the
the
curve.
formula. Value, remember. What is the value for average current?
0.617.
0.637 IM.
into IM. Okay. So for today's class, okay, I'll be releasing the material by today evening, this document. Okay. In this group only I'll keep, okay, so that it is visible for all EEE and EC also. Okay. So now any question is there, you ask any student. So today you see the pole near your house and tell me how many wires are connected to the pole, and from the pole how many wires are coming to your house, Understood, all of you? Okay.
Okay.
Better you take this screenshot, then every neighbors will understand that you are really studying the engineering, first thing. Okay. So you do that one. How many wires are coming to your house and how many wires are connected to the pole? Now, that is in Infosys. Anybody has gone through the website of Infosys products?
Yes, sir.
Okay,
Yes,
what is
sir.
the product? Okay, I'll check that one later on in tomorrow's class. Infosys, IBM, Wipro. 3 companies website you open and you read the names of the products, because what every company will do, they develop the product. Product means any common person can use that product. When I say the project, it is common person cannot use that project. Okay, that is a different. Our aim is to develop the products only. Design and develop the product. Which product you can develop by using BW subject? Anyone tell me till now? By using BW subject, which product you can develop? Imagine one day I have taken one project first week. What is the name of that project? Robotic snake. Yes, you know the application. Anyone tell me what is the application of that project? If one Indian soldier is attacked by 10 Chinese soldiers, even if Indian soldier is not having the weapon, he can use that remote control robotic snake. Robotic snake identifies who is Chinese soldier and who is Indian soldier, and it will kill the Chinese soldiers. Tell me. No, it will make the Chinese soldiers to unconscious state, and therefore we are introducing the humanity in our project. Okay, so who will buy that project? Anyone tell me?
Army.
Very good. Indian military people, if you listen, if you develop that one, if you write the program, and if you explain that concept to the Indian military organization, one day we will get the chance. I'll make you people the perfect team. I'm going to select from your batch, and they will be given training. They are going to explain to the Indian military people. Okay, like this, each project we are going to develop every weekend. So tomorrow's class will come up with the RMS current. Okay, and derivation. Right. Any question you can ask anyone? Last 1 minute is there. Okay, right. If no question is there, I'm just ending. Right.
Okay, sir.
Thank you.
Okay, so thank you.